Today's topic is web-based programming. The learning objectives are to explain the fundamentals of web-based programming, explain the key components of web-based programming, describe the technologies and frameworks for web-based programming, and highlight key considerations and technologies involved in web-based programming for DNA databases. Let's look at web-based programming. Web-based programming refers to the development of applications, websites, and services that are accessible through a web browser. So usually when you develop an application that you can access through your web browser, like your Internet Explorer, like your Google Chrome. If you can use Google Chrome to access a particular resource, then you know that that program was developed, that application is a web-based program. So this type of programming involves using technologies as HTML, CSS, and JavaScript for the front end side, that is the client side, as well as the server-side technologies for handling the logic and data processing. So web-based programming is essential for creating a wide range of applications. So many of the applications that we use today are developed by web-based programming, especially applications that we access on the website, on the internet. They are developed by web-based programming. So developers often need a combination of front-end and back-end skills to be able to build a full stack of web-based applications. So it's good for a developer to have not just the front-end skills, but also the back-end skills, have the right combination of both to be able to develop a web-based program. So the main features of web-based platforms include accessible via web browsers. As I said before, a web-based platform can easily be accessed using any of your web browsers like Internet Explorer or Firefox or Google Chrome. If you can access a software application through the browsers, then you know that that software application was developed using web-based programming. Other main features include cross-platform compatibility. It is compatible across various platforms. It's not restricted. And it also requires internet connectivity. It's essential in most cases to have access to the internet before you can access web-based programs. Then it has centralized updates and maintenance. The updates are usually centralized. So let's move on. Let's look at the core technologies of web-based platforms. One is client-side technologies, which is what happens at the front end. At the front end, we have three major programming languages, which is the HTML, CSS, and JavaScript. Those are the technologies that are often used at the front end. The HTML is your hypertext markup language. HTML is the standard markup language that is often used to create the structure of web pages. CSS, which is cascading style sheets, is styling and takes care of styling and creating a decent layout for your web-based program. It allows developers to control the appearance of HTML elements, providing the design and presentation for web pages. So it's essentially needed for styling and creating a good layout. Then we have JavaScript, which adds interactivity and dynamic content. It enables your web-based program to be dynamic on web pages. It runs in the browser and can be used for client-side scripting to create interactive and responsive user interfaces. The core technologies of web-based platforms also include the server-side technologies, which are usually what happens at the back end. The main programming languages that are used to develop the back end of a web-based program are PHP. You can either use PHP or use Python with Django and Flask, or you can use Ruby, you can use Java with Spring, you can use C# with ASP.NET. The key frameworks include Express.js, Laravel, and Rails. These are the frameworks that are used to develop the back end of your web-based program. The databases. Web-based applications often need to store and retrieve data. It's very important. So the main database programs are usually your MySQL. MySQL is the main database program. Also, we have PostgreSQL and MongoDB. We also have Oracle that can be used to develop the back end, the databases of the back end. Then for communication protocols, the main communication protocols are HTTP/HTTPS, which are the protocols for data exchange between the client and the server. So enabling communication between the client and the server. Then also we have AJAX. AJAX is another important communication protocol that enables asynchronous updates. Then we have WebSockets, which provides real-time communication. Then we have APIs. An application programming interface is a set of rules, protocols, and tools that allow different software applications to communicate with each other. So it allows different software applications to be able to communicate. So in web-based programming, an API provides a structured way for a client to interact with a server in order to be able to retrieve or send data. So that is very important. Key examples of APIs that are used in web-based program include REST, which is also known as representational state transfer. It's the most common architecture for web-based APIs. We also have GraphQL and SOAP. SOAP, which simply means Simple Object Access Protocol, is the protocol for structured data exchange. Web-based programming for DNA databases. Web-based programming for DNA databases usually involves creating and maintaining online platforms that store, manage, and analyze DNA information. These databases play a crucial role in various fields, such as genetics, forensics, and considerations for implementing web-based programming for DNA databases. The key considerations for implementing web-based programming for DNA databases include database management system. In order to implement web-based programming for DNA databases, one of the first things you need to do is to choose a database management system. We need to choose an appropriate database system to store and retrieve DNA data efficiently. We often use relational databases like MySQL or even Oracle. So they are often used as DNA databases. We can also have NoSQL databases like MongoDB. They can also be used in designing a DNA database. Secondly, let's talk about the web front-end development. For the front end, HTML, CSS, and JavaScript are usually the programming languages used. These fundamental web technologies are used to create the user interface for accessing and interacting with the DNA database. MySQL is used to write the web page, while CSS is used for styling and layout. Then JavaScript is used to make the front end dynamic and interactive. The front-end frameworks are also used for the web front-end development. We utilize front-end frameworks like React.js, Angular, or Vue.js. We use them to build dynamic and responsive user interfaces. The third one is the back-end development. The back-end is the server side, and the languages and frameworks used for the server-side programming include Java. We can use Java or Python or Node.js along with frameworks like Django, Flask, Spring, or Express to handle data processing. So for the back-end development, most cases you use Python. And when you're using Python, you can use the Django framework or Flask. For the API development, design and implementation of APIs to enable communication between the front end and the back end of the DNA databases. In trying to do that, we use RESTful APIs. RESTful APIs are used to enable interaction between the front end and the back end of the DNA database. For the sake of security, data encryption is often done. Normally, we implement encryption protocols like HTTPS to secure data transmitted between the client and the server. So encryption is often implemented like the HTTPS to secure data that is transmitted between the client and the server. Access control is also important. Access control is used to implement proper access control mechanisms to ensure that only authorized users can access and modify sensitive DNA data. So with access control, those who do not have, are not required, and who do not have certain functions on the system are not given access. So only certain people of responsibility, for example, the system administrator, the management staff, specific management staff, have certain access control rights to be able to control system. Not every user has a right to modify sensitive DNA data. So access control is important. Then authentication and authorization. We use authentication to enable users to log into the system. Authentication helps us to identify the users. So they are usually authenticated by inputting their usernames and passwords. And they can also implement authorization mechanisms to control their access level within the system. So authorization gives the user access to do certain things on the system. If a user is not authorized to do certain things, then he will not be able to do it. The next is data privacy and compliance. Ensure that the DNA database complies with relevant data protection and privacy regulations. It must comply with the relevant data protection, and we have some of them like the GDPR and HIPAA. HIPAA is the Health Information Portability and Accountability Act. So depending on the context of use, you should try and implement some form of data privacy and compliance to regulations. The front-end web programming for a DNA database using HTML. A DNA database is a digital or physical repository designed to store, manage, and analyze information related to DNA sequences. So it is used to record and organize genetic information. So with the DNA database, genetic information which are used for various purposes like research, like in healthcare, like in law enforcement, are implemented. The benefits of web-based interfaces for DNA databases include accessibility. Yes, with DNA databases, you can access the information about a person's DNA. Ease of interaction. There can be easy interaction with the database when we have a good web-based interface. A good web-based interface will allow the user to interact with the DNA database. And the web-based interface should also be user-friendly. So when designing a web-based interface, you design a web-based interface that is user-friendly. That will enable the user to easily key in information into the DNA database. The front-end requirements for a DNA database. The main features of the user interface of the DNA database are inclusion of form to impute DNA sequence data. So on the user interface, there should be a form that will allow the user to impute DNA sequence data. That is very important. So you structure the form to be able to accept DNA sequence data. Also, another feature of the user interface of a DNA database are it has options to query the database. So when you are designing the front end of a DNA database, you need to include options for querying the database. For example, by DNA ID or sequence patterns, you can query the database by putting a form in the form, the DNA ID, so that once the person types, picks the ID of the certain DNA and types it on that form, you can access the DNA. Or if we input the sequence patterns, you can access the specific DNA. Also, it should include table to display search results. When we search a particular DNA, usually the results are displayed in tables. So when you are designing the user interface of the DNA database, you should include the table, which will help to display search results. Then visualization tools is very important. It shows the sequences in color-coded format. It shows you the DNA sequences. After designing the front end using HTML, because the front end is often designed, the front end of the user interface of the DNA database are often designed using HTML. You will now use CSS. The HTML interface will now be integrated with the cascading styling sheets, which is CSS, so that the web page will have a well-structured layout and style. Then JavaScript will now be used to enable interactivity. So in this lecture, we discussed the fundamentals of web-based programming and explained the major components of web-based programming. The lecture also discussed important considerations and technologies involved in web-based programming for DNA databases. Thank you.